Okay. Alright, so I made a mistake last time. So it's not true that CK has to be an EK. What's true is so this is not true. This is um what was it? It was the inverse. That has to be an EK. And that doesn't necessarily mean CK. Okay, so what happens if that's the case? That means we don't describe them in terms of containment of ease. Okay, so let's see. Hmm. Hmm. Okay, so this is clearly so it's clearly so when we're writing this, we're clearly saying it's a simple function, right? Um, so why is that? It's because of this. So we have a measurable space. F is a simple function, and C1 to Cn are distinct non-zero values of F. Then F can be written in terms of the sum of the CK's times the characteristic function. And okay, so I think what's happening here So that would probably make this fall. This is not true either then. I mean, in general it is true to write it this way. So I guess I can leave it. Um, let's see. So if if we're picking the EKs to coincide with the inverse image of the CKs, and this definitely holds. But the way the result is like kind of wording it is a little bit awkward, I guess. At least it is for me, because we're supposing the EKs are disjoint sets, and we're supposing the C's are 0 to infinity. But we don't establish a relationship between them. Like that may be established here, but it seems awkward to do it like that. Let's see. It's like the only piece I need to resolve this. Does this imply that CK's, the inverse image of the CK is in EK? I think it does. Wait a minute. Does it matter? Hmm. I don't think it. Okay, let me think. So yeah, it is. Yeah, it has to be. It has to be it has to be true that F inverse of C. Actually, I should not write this like this. I should be like this. Yeah. Yeah, it has to be the case because the issue so the characteristic function is um defined like this. It's defined like this, and so it's equal to 1 if x is in ek and 0 if x is not in ek. So that means if we take um, the inverse image of this for 1, that has to be um, that needs to be contained in ek. Right, so obviously if we multiply it by a scalar, we have this relationship, and then we have basically have ck ek inverse of ck, which is just an ek. Yeah, scalar multiplying it, the characteristic function by a constant, by some scalar, like automatically means that the inverse image of the constant has to be contained in E sub k. So what was I doing here? And so when we look at this, we're taking the infimum over E1, and E1 is disjoint from E2 and E3 and E4. So the infimum over E1 means we're only looking at this part of the function, this interval, and we neglect these other ones. And then that causes it to choose C1. So this is equal to mu1, mu E1 infimum over E1 C1 E1 plus the mu E2 times the infimum over E2 times C2 times the characters. I mean, the infimum over E2 of C2 times the characteristic function on E2. Okay. E4, and yeah, so this is just gonna work exactly like it said. I guess I was overthinking it. I definitely cleared up that weird thing that I was thinking that the constants have to be contained in E for some reason. I don't know where I got that idea from. That's weird. E4, and then so this becomes the measure of E1, and so taking the infimum of this function, this function is just a constant function over E1, right? So we're in E1, so it has to equal to C1. So this is just equal to C1. And the same thing is true for the rest. Whoa. That was scary. Right, which is just a sum. Okay. Okay, that's resolved. I'm gonna delete this because this would confuse me if I look at it later. Oh shit. Yeah, this is confusing. So it doesn't even matter if they're equal. It doesn't matter if they're equal. It just matters that you're taking. So you start off with a sum of characteristic functions defined on X, which is broken down to partitions EK, and then you're taking the scalars, you're multiplying each of those characteristic functions by a scalar, which is basically shifting. It's basically shifting the constant function 1 to different locations. And they can have, and so like, it's possible that like you can have E1 and E2 that have the same constant function, and that's totally okay. Because we're taking the infimum over each disjoint set, and that's only going to select one out of the n functions. Yeah. Okay, so what I have here, I said Cj is the only value in Ej, which implies the infimum. Yeah, this is true. Yeah, it's crazy how I was tripped up by this. Let's see. Okay. Post piece in this partition. Okay. Okay, I worked this out last time. What I do here? Okay, so it's the infimum to the minimum because um, because it's the infimum instead of, so it's the minimum. We get the minimum because we're the value that we're selecting is in the set. And then A is a partition of X as well, but it's arbitrary. So we take the intersection of A, J with E, I, at least the non-empty ones. So we have all the EIs. How do I think about this? The measure of AJ is equal to the sum of the measures of AJ intersect AK, EK. Okay, that makes sense. And that makes sense. The union makes sense. Okay. What did I do here? Did I mislabel this? Yeah, I did. No, I didn't. We're taking the intersection of AJ and EI, so all of the ones that are non-empty. I think I missed a step here. Lurk GG study. Thanks for the lurk. Hey Paps. That Jiggly looks so strange. I remember it's Rezzy's, but like the eyes just look so strange. It's past my bedtime. It's barely 7 or 8. Let's see. Let's see. I need to think about this. Okay, so there are these sets EK. This is EK, or E1, E2, E3, E4, And this is C1, this is C2. Well, let's just write it here. C1, C2, C3, C4. Okay, and then A is another partition. Is it disjoint? I don't think it is. Suppose P is an S partition. Suppose S is a sigma algebra on a set X, an S partition of X on a finite collection is a finite collection. Oh, they're disjoint sets. Yeah. They're disjoint sets by definition. Okay, so they are disjoint. All right, let me just draw them in random spots. So let's suppose that this is that's A1, A2, A3, A4, A5. Let's just make this last one A6. Okay. So the minimum of the simple function. So if we talk about A1 has these two. So let's see. Which is so it's involving these two, and then that's because it's intersecting E2 and E1. So I think I need to rewrite this. I think this is not good. The minimum of the intersection of AJ and EI. There's a step before this. Hmm. 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 Maybe it does work. How do they index it here? They index it with K and then they switch it with I. Guess that makes sense. Yeah, I think this is fine. Because it's basically selecting all the index i's that satisfy the intersections that are not empty with aj. And so in this case, that's index 1 and 2. So we have 1 and 2. And then we have I guess this actually just jumps. Just jumps to this. Interesting. There might be a way to write it. There might be a way to write one more step in between here. I'm not sure though. The minimum. I wonder if I can write it like this. It might not be necessary, but it might just kind of like shed light. I can write this as the sum from j to m of mu aj of the min, times the min over um, over the intersection of aj and ek, not empty. I think this is fine. I do want to keep this because this was kind of clearing it up. What the heck? This cleared it up for me, this simple example. So let's put it somewhere to the side. Since I can delete. Okay. Oh shit. I put this right here. And what I'm gonna do is I'm gonna move this to the right. Me changing my writing or my pencil is like changing my notes. My notes are becoming different fonts now. This is going here. Yeah, this is the min, and so the min is still taking over the sum. K is equal to 1 to of ck times the characteristic function. I gotta be careful with this. Ek. Yeah. So we're taking we're basically taking the intersection of AJ and, oops, this is supposed to be not empty, over that's not empty. Taking the minimum over the sets such that AJ intersect EK is not empty. And I think this leads to this, basically directly. Right, because last time what happens is we took the infimum over the E sub k's, and that one would select the C sub k from the sum. But this time it's AJ, and AJ can be over multiple E sub k's, like the example that I just drew. And so we specifically say that AJ, and we want the AJs that intersect EKs such that they're not empty sets, and then that isolates which C sub k's we are specifically looking at. So there are multiple of them. There's a list of them. So this is like, so that leads to this. And then what happens here? Are you learning, Pabs? Are you learning? I need a note-taking emoji. Like that one. Do I have any note-taking? Note-taking? No, not any good ones. Or not any, like, I don't have any, like, moving ones. I have this one. Yeah, I need SpongeBob taking... I think there is a SpongeBob taking notes scene, actually. Yeah, that has to be... Yeah, it's actually Patrick taking notes, but there's also one... there's also one... As you can see, that the scene where he's, like, writing things down, this is like the bear episode. This is a good one. I forgot he was playing tic-tac-toe. Oh man, this freaking show is just too good. And then there's also this one. This is good. Oh man, I want these on my emoji set. Man. These would be good. Oh, this was good too, actually. I forgot he does this too. This is like one of the early episodes. I think this is actually the first episode. When he's about to get hired and they tell him to go buy a spatula. Just wait till Resi streams it. Let's see it. I'm waiting for I'm waiting for my girlfriend to draw it, to be honest, but I don't know when that's gonna happen or if she's even gonna draw it. Wait, what am I doing here? Oh, this is also good actually. God, SpongeBob has so many good like scenes that can be used as emojis. One of these days he'll stream it. Let's see. You know, I kind of share the same gap in SpongeBob as Rezi. I think I only know the references rather than having ever watched the full episode. Oh, the full show. Well, I mean, you at least know some of the references. I don't know how well it would be like now. Like how good is it now? Like it was good like when it was on Nickelodeon. Like when it was like releasing, putting on episodes. I don't know if it's good if it's going to be well received anymore. Some jokes are just good in a certain era. Oh, you used to be obsessed with Flapjack. Flapjack was a lot of the Cartoon Network shows were actually very they're like pioneers. Like a lot of they're very different from each other. They're like kind of pushing boundaries. Like Flapjack, Ed and Eddie, Powerpuff Girls. Like those were all like bangers back in the day. Imaginary Friends. But now I don't know. I think Cartoon Network is dead, if I remember correctly. Cartoon Network. History, programming, original series, programming blocks, editing. I don't know. I don't see it. Maybe it's still around. Maybe it is like in it looks like HBO or Max. Is Cartoon Network dead? Both the network and the advocacy group have since stated that is not true. Okay, maybe I just got bad fake news or something. I wouldn't know. I don't have cable anymore, so like I have no idea what networks are still around. Let's see. Go from this to this. Why does it become a double sum? Oh wait, I think I have it actually. The measure of AJ is actually equal to the sum of the measures of AJ intersect AK. That's true. So that is. Did I not write that? What did I write? Well, I guess I rewrote this part, but the next step would be to add the sum. So mu of AJ is equal to. Holy moly. And so we can use this as the justification. This is equal to measure of, the sum of from J equals to 1 to M. And then this we're substituting with the sum from K is equal to 1 to N. Mu AJ intersect AK or EK times the min, of the sets of CIs such that AJ intersect EI is not empty. That's this right here. Okay, so far so good. And then what do we have next? The next thing is, so we have N on the inside. That's where I made the substitution. And that's less than or equal to this becoming CK. Okay, so that why is that the case? Why is that the case? Interesting. Holy moly. I'll figure this out before I end the stream. I will figure it out. Even if I had to write down the sum. Holy moly. Am I really gonna have to write this down? Okay, so if Ci is not equal to Ck, then oh my gosh, I'm gonna have to write this down. This sucks. Okay, let me see. Okay, we'll take this example. We're taking, it's still a lot of terms. J is equal to 1. So the measure can be 0 for some of the terms. Yeah, so the measure can be 0 here. So some of these terms 0 out. Fan Center, thanks for the raid. And Stucky, good to see you. Good morning. Is it morning? Welcome in, everybody. I should, hello, hello. Hello, Phobos. Yes, this is a measure theory. Yes. Integrating step functions looks like the beginnings of measure theory. Yes, 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 exactly. I'm working on some, the details of the proof. I'm just basically trying to go through like the the justifications for some of these steps. And it's like it's a little bit more time consuming than I expected. But yeah, I'm working on some measure theory right now. I'm on integration, specifically like integration of simple functions. Well, reference, this is the Axler book. So this is Axler's introduction to like measure theory, integration, and like etc. I'm also looking through the other book, Royden, the other one that's the one that a lot of people use as well. I need to learn measure theory. It's good. It's very interesting. A lot of set theory and topology like applications. But when I took this class, which was a year ago, I learned it through this book, and my exposure to it was a little bit. I didn't fully grasp it when I took it, so I went through it again in the summer, and I got pretty far, but it was a lot of details I had to fill in for chapter 2. So I'm currently on chapter 3. I learned in grad school we use Rudin's real complex. Yeah. That's another book that I haven't fully looked into it, but I am planning on referencing it just to see what the differences are. But that one is like obviously that one's notorious, just like the Baby Rudin book, right? I was told that book is like the book to read for this. It's like it has everything. But since my exposure was through this book, I wanted to at least like get a good understanding of everything that's written in this book, and then maybe like go into like Rudin's or Royden's book. Yeah. There's a third Rudin book, which I actually have a hard copy of. That's the functional analysis. Yeah. Thank you, Pencer. I really appreciate the raid. How did you even find out about me? To be honest, I thought I was kind of low key. Yeah. So, what am I doing here? I'm trying to justify this step here. So this step between basically this inequality. I posted my Twitch handle on Craigslist. Oh, great. Okay. Why is this bigger in general than the min? Case. Yeah, that's what I'm thinking, but I'm not sure why. Because the sum over all the k's, like AJ, it doesn't intersect with all of the EKs, like assuming that like AJ doesn't intersect with every EK, right? So it has to be empty, so the measures have to be 0 for some Ks. It's the first time I'm in the math Twitch channel. where I'm completely clueless. Oh, what's your exposure? Some of these are, so some of these zero out. Some of them do zero out for some K. First chapter is a baby ridden. Well, that's a good chapter to be in. Doesn't that cover like the the construction of the real numbers? Looking at the intersection where the minimum where the intersection is non-trivial. But for any k where aj and ek intersect non-trivially, ck will be bigger than the minimum over all such I because k is one of the possible i's. Yeah, so you're looking specifically at the intersection that is not empty, right? And then the minimum picks out the smallest value. So the ck that we are picking can either be ci or the minimum or anything above the minimum that has a non-empty. Okay, yeah, that makes sense. Okay, that makes so much sense. Because I was thinking that's so clear. I was thinking the idea like when I constructed like this simple example, like a1 has like these two possible constant functions that's associated to, and so the minimum will select the smallest one, right? But it technically has two, I guess, and so ck is allowed to be presumably the smallest one or the big or any one in that non-empty intersection. Am I like kind of reading that correctly? The key is the equal symbol. It seems like. Okay. A shot pen center. Yes. And then this was ck. How do I write this? How about I like write it in a compact way? All of the individual elements of the set are at least as big as the soup. Oh, okay. But I understand. I understand exactly what you're saying. So even though like we're indexing on ck, like if the intersection is the empty set, then that goes to 0. But if it's not empty, then ck can be the minimum, but it can be something that's bigger. That's also contained in the. That's also contained in. Okay. That's also contained basically on the output of the simple function that's basically over the intersection. What happened here? Why is it like missing something? What the heck? Okay. Yeah, that makes sense. Let me write a quick note about this here. Um, FHA. Then I know exactly the reason. I can't like put the words. I can't put the words on paper. How can I write this? It's right here. Hmm. Should I even use the same index? Is actually a good source for self-study for measure theory because Royden is 180. Honestly, I really liked Axler's introduction to measure theory. The it's like it's obviously not as complete as Royden or or Rudin, but it has like all the main details and like really as long as your like real analysis, like your undergrad real analysis is solid, um, this would be a really good introduction to measure theory. A lot of the undergrad stuff is not written down explicitly in the book. I mean, for good reason because it's a graduate book, right? So you can't really get bogged down on all the details um, for a variety of reasons. One reason would be like the book would be a lot bigger. But yeah, like when I reviewed Real Analysis and went straight into this book a second time, like the book was a lot more friendly and clear and yeah, I honestly think this is a really good book for at least an introduction. Compared to like Royden's book, I don't know if I have it here. Yeah, I have it right here. Like I made this comment last time, but I hate the way it looks. I just don't like the way it looks. It just looks so like I have difficulties finding things in this book, to be honest. Like it's not obvious where things are, like what specific theorems I'm looking for. Like it's not obvious unless I use the index, obviously. But I would like to just go through in a chapter and just like be able to kind of skim through pages and know exactly like find exactly what I'm looking for. You know. Okay, I decided to go with Nebo since GoodNotes writing to LaTeX is still experimental. Okay. I actually don't know what Nebo is. The heck is Nebo? AI note-taking app. I see. I didn't even know this existed. I only really knew about Notability and GoodNotes, and obviously the Microsoft note-taking app. Springer books are tough to filter. I like things in boxes. Yeah. It's I think you guys are familiar probably with Axler's other book. It's very famous, or at least it is where I'm from. His linear algebra book. Where is it at? This one right here. I have like the older edition, but like he just released the newer one. I think this book is really good too, actually. It's famous enough to inspire another book, Linear Algebra Done Wrong. Actually, it's the name is so it's so funny to me that I actually based my notes on um on that on that specific phrase. Axler done again, basically. It is very Stewart calculus or Anton linear algebra of me. Anton, that name sounds familiar. Anton. Oh yeah, I know Anton. I know. I think I have that book in my. I may have that book. Anyways, I'm not gonna look through it because I have like so many books on my iPad. I like non-narrating books. I feel like it confuses me more. Axler, LADR, for instance, or Robert Ashe, Basic Algebra. So you don't like the like when people kind of like have dialogue in their book? Is that what I'm saying? You just want the definitions and the theorems and bam bam bam. Avoiding determinants is reasonable if you're trying to do functional analysis on infinite dimensional spaces, but it makes things worse for finite dimensional stuff. I actually didn't know that. Is it really? Is it really that important in finite dimensional vector spaces? Because as from what I can tell, when you do like numerical algorithms, um, it's mainly based off like, and make sure you correct me if I'm wrong. It's mainly based on like row echelon stuff, right? Like row echelon operations and not really determinant heavy, or maybe I'm wrong. Oh, it makes things significantly cleaner. Yeah, yeah. I actually, I I'm either or, to be honest. Like whether you do determinants first or last is like, I like them both. I guess it's nice to see both like both ways of doing it. Numerical algorithms have other concerns, like convergence. Okay, I transfer my books to my tab. I do like one thing is to narrate. Another is to give a context, which is what Axler does. Okay. Any Axler fans in the chat? He's got one more book, which is the harmonic theory, but it's like not, it's not written purely by him. It's like co-authored by I think the two other people. You don't think you read an Axler book? Yeah, I've noticed that some people don't ever touch that. I think they either, I think they read the other one, which is who's the other guy? Where's the other guy? I know he's in here somewhere. I said I wouldn't go through my books. Like Strang. Strang is another common book people use. Um, where the heck is it? Oh, there it is. This guy, Friedberg. This is another one. This is actually the one I used, like when I first took linear. Yeah, Strang has YouTube lectures to accompany. They're very good. I get sleepy reading the narrative too. Yeah, this is pretty good. It's also like a common like undergrad book. How much does a non-analysis have to know analysis for grad? That's a good question. I think as long as you have undergrad real, like solid, like you're proficient at it, like you should be able to navigate through like at least at least measure theory and some functional analysis. That's at least been my experience. I missed out on taking linear algebra with Strang because I already took it in high school, though I got to take algebra with Artin and topology with Moncrief. You actually took those actual professors, or you used their books? That's insane. If you were like actually in those classes, or maybe they're like, I don't even know how old they are. Like I'm a little clueless about the ages of some of these authors. Those actual professors, that's insane. That is insane. Oh, he came out of retirement to teach the class? Dang, that's cool. Man, that is so awesome. I wish I had an experience like that. Learning from like these like famous math authors. Moncrief has like what, a good topology book, if I remember correctly. And this one, Manifolds. Did you take? Oh, you took. I'm assuming you took topology, right? Yeah, topology. Yeah, that is crazy. Taking those two is like I would never have. I would never even hope to take those guys or anyone like it at that caliber. He kept on saying things were Mickey Mouse, and I didn't exactly know what he meant. His point set topology book is the standard. Yeah, yeah. I use Yeah, this is very good. That topology book, and it's good to kind of supplement it with something that's a little bit softer, which is this book. I don't know I don't know how common this book is for everybody, but I used this specific book. But when I took topology, like I was actually reading through the Moncrief's book as well. That's a good portion of the 20th century math right there. There's just so many good books. Unfortunately, I can't say I when I took analysis I used Rudin. I had to use Goguen. I don't know if I pronounced that name right. Which I think is also pretty good. I saw one of the authors there was Colin Adams. I wonder if he has any relation to the famous topologist Frank Adams. The closest experience I have with famous academic is getting mentored by a mentee of a Nobel laureate. Hey, you're very that's close enough. Let's see. Well, was I done with this? I was gonna finish stream right after I finished this proof, and I think I'm like right at the end actually. But I definitely appreciate like the help. Like if anyone in chat helps me with like or like gives me insight on like things like this where like the minimum of all the CIs is less than or equal to CK, like that is so awesome. I use Michael Taylor for advanced calculus. Everything else is curiosity self-study, which is basically nothing. I wouldn't say it's nothing. I'm not quite familiar with Michael Taylor though. Michael Taylor. I googled Michael Taylor. I got a baseball player. I should probably put advanced calculus. Interesting. Looks cool. I put it on the list. All right, let's finish this theorem. So here I have it's so these are basically finite sums, and then you can basically um, so what's happening here? This only depends on ck, right? So ck is for sure needs to stick with the so this term here is sum over k and j, right? But since these are finite sums, you can kind of switch the order of the index. And this one, since it's just ck, since it's only indexed by k, it has to stick with it should stick with the sum that's indexed by k. So that's the reason why that's separated like this. I should have like the coffee is ready. Perfect timing, 9 p.m. Okay, I think that's good enough. All right, I'm gonna delete this because I'm done with using this. And so this becomes and this is because we can switch the order of the we can either sum j or we can sum k for the measure because the sums are finite. Okay, and then when we sum over the measure of aj intersect ek, we get the measure of ek. Hmm? Okay, this leads to k is equal to 1 to n ck measure ek. Okay, so why is that? AJ the union of AJ intersect EK is a subset of AJ. Presumably the EK are disjoint, and so the intersections are partition of AJ. Yeah. They are definitely disjoint, and so the intersections are partitions of AJ. Yeah. Okay. Yeah, that makes sense. And so if when we take the sum, you basically arrive at the measure of EK piece by piece. Was this true? Wait, let me think about this. This is true, right? AJ intersect EK. Yeah, of course. No. This is contained in AJ. Is the union? AJ intersect EK is contained in AJ. I'm playing video games. No worries. Yeah, your input has been very helpful. Yeah, I think this is true actually, because each of these is contained in AJ. So if we take the union, they should also be contained in AJ. Yeah, finite additivity of disjoint sets. So this so what I'm trying to like get here is that basically the union J is equal to 1 of AJ intersect EK should equal to EK. AJ partitions the EK, right? AJ and EK are disjoint sets, but AJ being a disjoint set, that also is a S partition of X, allows it to partition each EK. So because of this, this leads to, let me see this. Oh, I shouldn't really release that. The partition of EK because A1 to AM is also an S partition. Holy moly. Of X. So we have this, which implies that the measure this implies that the measure J is equal to 1, AJ intersect EK. This is equal to the sum of the individual measures. And this is equal to, I'm writing this like probably in the wrong order. Which is equal to the measure of EK. Blue is fine. Okay, there you go. That's the justification. Hey, bro, what we do? We're doing measure theory. I'm doing some measure theory. We're about to be finished though. And this is it's the last step. And inequality above implies, okay, we have the less than, right? So we have the Lebesgue, the lower Lebesgue sum is less than this sum. And the lower Lebesgue sum is also, okay, so we get lower Lebesgue sum. What am I doing? I'm just studying. Or, yeah, I'm studying. I'm glad to see you mathing on Twitch. It's good to see you again. How are you doing? Copy this. So this is less than or equal to Did I get the index wrong? N. It's K to N. What did I do here? It's K to N. Yeah. Yeah, it's fine. Okay. Phew. I thought I got the index wrong for a second. Holy shit. Okay. Just copy and paste so I don't have to. Okay. Doing pretty well. Should be sleeping though. Yeah, it's nighttime. What school am I in? You don't have to answer if I want. I'm in a school in Pomona, so um, not sure if I want to say this school, but I think that gives you like a good rough idea of like what schools are like possible. Pomona, California. iPad looks nice. Have you got any recommendations for me for note apps? I just got my first ever iPad a few weeks ago. I probably need to get an Apple Pencil too. Yeah, probably. If you're, especially if you're writing notes. I don't know if other um, writing writing um, pencils or tablet pencils or pens or whatever they call them work well with the Apple products. But yeah, you would have to spend like another $100 on an Apple Pencil. As for note-taking apps, the standard ones that people use are, if they're gonna like pay out of pocket, are. We were just talking about this earlier, actually. Do I have? Oh, right. I use GoodNotes. But yeah, the good thing about typing one of the apps is usually you will get the other ones too. So I have GoodNotes 6. Other people use Notability. And then there's also people who use Nebo, what I just learned about today. Joseph in chat kind of mentioned that they wanted a note-taking app that has AI, some AI capability, which will allow them to like um, use LaTeX for their note-taking app. I think I think what it does is it like turns your handwriting into like um, typeset. That's at least the impression that I got. But I mean, these apps are obviously gonna like cost you like $10 or something or $20. It and some of them are subscription based, but I also heard that there's a one-time flat fee, which is a little bit like more expensive. Do I know Professor Goins? I don't know Professor Goins, unfortunately. Make sure your pencil is also compatible with the version of iPad you have. Oh, that's true. Yes. If you have there's like two versions. There's like an older version that like has like a tip at the end. I think I think that one's only compatible with like some of like the lower models or the older iPads. But if you have like this one, which I think charges, I don't think I know it charges wirelessly, which charges wirelessly. This one should be compatible with like the Pros and stuff like that. Yeah. So if you are planning on getting an Apple Pencil, you just have to make sure it's compatible with your iPad. And Stucky, I just realized a couple of days ago when I was watching your stream, the that your Twitch name is based off your real name. Is that true? It's like kind of like an abbreviation of it. Oh, your professional name. Okay, okay, okay. Yeah, nice. Okay, so we got this. And then the definition of the integral, it depends on the supremum of the lower Lebesgue sums. So Okay. My brain is like half turned off. I've done the supremum, this exact supremum justification like at least over 20 times, and I'm a little bit slow to recall. So like the integral, I guess I should just write it down. The integral of the simple functions k equal to 1 ck ek. This was d mu. This is equal to the supremum of all the lower Lebesgue sums Gonna make sure I write it. P is an S partition of X. Okay. So that tells you, this basically tells you that this guy, this guy is less than or equal to this guy, right? Because these are all the upper bounds. No. This is the least upper bound of everything in the set. So this is actually less than or equal to this. Professor Gaines does everything. I like. What is it that Professor Gaines coins? Yeah, I'm probably even pronouncing it wrong. Apologies if I do. What subjects do they teach? Nice textbook collection you have. Thank you. Unfortunately, I can't say I read all of the books I have. They're just like some of them were interests. Like this real analysis book here, the modern techniques, is kind of like just supplemental interests or just like an extra resource that I have. But a lot of these I actually have read. Not the survey. I'm still working through the numerical stuff. Not the partial differential equation stuff. That is like something I need to get to though eventually. Okay, so the integral is the least upper bound of the lower Lebesgue sums, right? So it's for sure true that this is that the lower Lebesgue sum, which I will just copy and paste it because I already have it ready. That this is less than or equal to the integral by the definition of the supremum. But I think there is a theorem. There's a theorem that basically tells you there's a theorem that basically tells you that there exists an element in the set, in this case the set of low Lebesgue sums, such that this is greater than the integral plus some epsilon. Oh, that's right. You're a physics guy. Yes, yes. I have exposure to physics. Are you planning on being an analyst? My kind of ambitions are a little bit more I'm planning on teaching. I mean, it's either teaching or doing some sort of job that requires me to use like some of the physics that I know. So one part of my goal here is to also learn numerical analysis, which I did start a little bit in the summer, but I haven't really I took a break from it because I ran into some coding issues that I still kind of don't want to work through. But I either want to teach or do something like that. And yeah, I'm not trying to do any high level research and analysis or anything like that. But at the moment, I am focused. I'm currently focused on building this skill, analysis, because it was it's kind of like my analysis treatment was my analysis experience was really poor during my undergrad, and part of that is because I took it during the pandemic. So the switch to online was very it was a lot. The way things were handled in the classroom was much very different from the online format. We had I think 2 hours in the classroom, and then that turned into 10-15 minutes of videos, 2 or 3 10 to 15 minute videos on big theorems. So it wasn't very an enjoyable experience for me. I needed to be in the classroom and iron out or work on these with everybody else, So part of my part of my goal as a graduate student was to basically build this skill, and I think I've gotten a lot of progress on this. At least I'm definitely. It's not. I think I know for sure. I've progressed a lot. I'm a lot different from when I first took this. I first took my undergrad analysis course. I'm much more comfortable with epsilon proofs and stuff like that. With dealing with supremums and infimums and stuff that and some topological ideas as well. That part of that was because I've taken a topology class. Math and physics, marriage made in heaven. Yes, I completely agree. I love both of those subjects, which is why I did my undergrad in both. If you think your analysis skills are poor, I had a friend in grad school who didn't take calculus or any analysis as an undergrad because he went to Brown, and they didn't require him to. Oh my. But he took a bunch of advanced algebra classes. I remember mentioning some basic properties of logs, and he started taking notes. I've never heard that before. That's crazy. It's sometimes good to put things into perspective, right? There's there's always someone that has a different experience that's probably more challenging. But yeah, a lot of this stuff is becoming much more natural to me. Sometimes I forget some things like what I just said right now, handling this case with the supremum. But it doesn't take me that long to kind of figure it out like it used to. Now I know what sort of analytical techniques are used commonly in analysis, I guess, is one way to put it. Granted, he also had a dropout. Oh no, no, not the dropout. To be fair, algebra is more accessible than analysis, in my opinion. Yeah, I honestly, algebra comes to me much more readily than analysis. But I've asked a couple of people about it. Some of the people that I asked were like faculty, and I also Googled this. Like, I did some research on Google, like as much as I could at least. And the consensus seems to be kind of split. Apparently, half the population seems to think analysis is easier than, or maybe accessible is not the same as easier, but that's kind of what I was looking for. Like I was trying to see, oh, is it just me? Am I having a hard time with analysis, or is it just generally like the the way it is when people with when math majors take analysis and algebra? So it seems to be split. Like some people find analysis a lot easier than algebra and vice versa. Analysis you can have a geometric intuition about, but algebra you're examining simple structures. The intuition is easier. I think algebra the intuition needs to be developed. Yeah, because like the advantage you have with analysis is like you've kind of seen it before, sort of, because of calculus. Like you've seen it from algebra, like from college algebra or whatever algebra treatment you've had in high school, like where you're dealing with like functions and domains and stuff like that, domains and ranges and kind of manipulating them. Um, but I think that's like the advantage that you have in analysis is like you've seen some of the stuff in those classes, but it still was so difficult for me. It's even more difficult when like you kind of know these things to be true, like some of the properties of the real numbers. It seems so simple, and then now you have to prove them. You can distinguish algebraists from analysts by how they eat corn. I've never seen that before. Oh my god, the screen continuous joke again. Is that like how how do you distinguish the difference? Let me look for this real quick. It's right here. The hardest things to prove are the ones where you say, "Wait a minute, isn't this just obvious?" Yes, exactly. It's so when I encounter that, I was like, man, not this again. I've gotten a little bit better about that though. Like things that are obvious, I've gotten better at proving um obvious things. I'm looking at 44. X is equal to the soup. Um, and there is an element in S such that A is less than or equal to X, or X minus epsilon. Did I get this wrong? There's no way I got this wrong. Did I get the order wrong? No, I did get it. I got it right. No, no, I got it wrong. I like messed it up. It's like this. Oh my. Oh my. Don't look. Don't look. I didn't write that. Oh, actually, this is still true. That's still true. This is less than. And this is the integral. minus epsilon. Okay, let's take a look at this. Oh my! Oh man. I'll read this right after this proof. As in, for algebra, you just use an extremely strong theorem and prove the proof is done. Hope for advisors not watching. Okay, does this work? Is this enough? Lower the big sum. What is the condition here? For each epsilon. So for each epsilon, there is a element in S. Yeah, this is basically. So what we have here is that this integral minus epsilon is less than the Lebesgue lower sum, but these are tied together, right? So for each epsilon there is a Lebesgue lower sum such that this is less than this, right? So I think this implies that this is less than this, right? Are you a math grad student? I'm applied to 9 so far. Hope to get in. I hope you get in too. I've enjoyed my experience so far. I can honestly do this like probably for fun. I can do it for fun for the rest of my life. It's really interesting. Um, 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 um. Yeah. So this is. I don't need to write this. This is. Let's turn it equal to this. What am I trying to get here? I'm trying to get. That the integral is less than this sum. Or less than or equal to this sum. Hmm. So this is basically, I think this is what it's saying. This sum is less than or equal to the lower Lebesgue sum. Wait, did I do this correct? Yeah, we start with the lower Lebesgue sum, right? So this is less than or equal to the lower Lebesgue sum. I mean, the lower Lebesgue sum is less than or equal to the sum. So so this is less than this, right? Because this comes from the supremum property, and it's basically for every epsilon, right? There exists some sort of lower Lebesgue sum, and so the inequalities that follow here is that this is less than this for every epsilon, and then this follows by the integral itself. K is equal to 1 of ck. The mu is just less than or equal to ck. Mu e sub k. Right, this is a property for inequalities. I think it's actually in the same book. For every epsilon. I know it's in here somewhere. Hey, Seth. Dang, you're awake at this hour? Okay. There has to be one that says for every epsilon. Where did I see it? I know that's a thing. It has to be. I think I wrote it on my 2A notes. Where is it at? This was the one I just used, similar one. And then this is, it's this one. Wait, it's less than? It's strictly less than? Hmm. 3a. Yeah, I think it's still strictly less than. This is for all. But I mean, less than or equals is still contained in less than. It's still contained in less than, right? So it's still okay. It's still appropriate to write it as less than or equal. I think this is fine. Bed's already calling to me. It's calling to me too. I'm actually about to end. But I think this concludes the proof. Let's see, where am I? Where am I? Yeah, because once we get the inequality in the other direction, we prove equality. And I think this is fine. I'll look at this when I'm a little bit more awake. So I'm gonna make it like a big circle here to remind me. Just this specific argument. Look again. All right, finish that one. Nice.